Well, that's all the Russian I can speak. So, welcome everyone. Before I start, there are a few questions I want to ask you. Please raise your hands if you have been involved in UI automation of mobile applications. And please raise your hands if you have used Appium. Oh, there are only a few, so it's going to be an interesting one. Because this talk is going to be based on the Appium heavily, but I'll try to explain as much as possible then. So welcome again to my talk. Yeah, my name is Rajdeep. I work at Badoo. For those who don't know, Badoo is the largest dating platform in the world with 350 million registered users. So we have an office in London and we have an office in Russia at Moscow. We have many mobile applications based on our dating platforms, and my responsibility is to take care of the UI automation of these applications. And my area of interest is specifically the Android platform. So I am heavily the user of heavily doing the Android UI automation. I've been working with Calabash, Espresso, UiAutomator, and recently I started working with Appium. And this talk is going to be based on how we have put some backdoors in our applications. And backdoor, I'll be explaining backdoor during the course of the talk, but it's one of my recent work with the Appium. And this is going to be the agenda today. I'll talk about some of the complex and common issues which we face in the UI automation field, especially for the mobile test automation. And then we'll talk about the solution, and I'll introduce backdoors, what backdoors are, and I'll show a demonstration of the backdoors, and then I'll show some real examples of how we use backdoors at Badoo. So let's get started. How many of you know this game? Please raise your hand if you do. Wow, a lot of you. This is one of my favorite game. This reminds me of my childhood. I used to play this game a lot, and I always used to win. I used to compete with my friends, and I always used to be ahead of them in this game. I always used to win. And the reason was not because I was a very good player, but I had unlocked a secret of this game. And the secret was this. So if you can read, the bottom line says twice up, twice down, left, right, left, right. Can anyone guess what it is? Immortality. Yeah, but what in terms of the gaming context, what is this called? Cheat codes, right? You got it. So this is a cheat code, and I used to use this cheat code a lot to win this game. This gives the 30 lives if you play this game, and that's basically enough to kill the enemy. Now I'm a tester now, and now I feel very curious. Why did the developers of this game put the cheat code in the game at the first place? Did they want their players to cheat? Can anyone guess why did they put the cheat code? For testing, yeah, you guessed it right. So they put the cheat code not for the users but for the testers, so that they could test the game easily. So for example, if some tester want to test the level 6 of the game, he could bypass all the levels by putting cheat code and just test the level 6 that he want. Now this is somewhat, some similar thing is available to us in our testing field also in software. So if anyone uses the Android phone here, there are some secret menu in the Android phones, right? The debug menu. You tap on the build number like 6-7 times and you unlock the developer option, and then there you can find a lot of hidden menu where you can play with the Android processor speed, or you can even alter the activity life cycle. You can keep, you can touch don't keep activities, and basically you can play with your operating system, alter the operating system so that you can test something. By the way, is there any developer in the room, Android developer by any chance? There's no one. Usually there is one, but anyways, so if you are a tester, sometimes developers put in some hidden settings in the application to test something. For example, if you want to change the backend URL of your application, you go to settings, but in the debug version of the app, you see some secret settings where you can change the app URL, things like this, right? So, but that's for manual testing, and today I'm going to talk more about automated testing using Appium. And do we need something similar for our automated tests, and is it possible? That's the question. So the answer is yes. If we could have this kind of superpowers in our application, it will make our life much more easier. And why we need it? So let's take a few examples and some of the problems which we face in UI automation. So I'm going to use the F word here. Yeah. So the Flaky app, yeah, not the Flaky test, but the Flaky app. Imagine your tests are running, tests are fine and robust, but there is a sudden pop-up or while your test is running. Pop-up can be rate us pop-up or give us feedback kind of pop-up, and they basically make your test fail. Now that was not a problem of test, but the app is behaving unpredictably here, right? So what if your tests could tell your app like, hey, I'm testing you, so please stop showing such random pop-ups. Now another problem is driver limitations. So if you are using Appium or no matter any other driver, sometimes you cannot do what you want. For example, let's say your application has a functionality wherein you shake the phone and something happens, or for example, you are writing a alarm application and you have a feature like if you flip the phone upside down, the alarm snooze, right? So how will you automate this case? So last time someone answered me that they will put a Raspberry Pi with a robotic arm, flip the phone, and they will test it that way. But anyways, this is a very difficult case to automate, right? So imagine your test could tell your app that, hey, I'm testing you, now I need to flip the phone. So assume that the phone has been flipped and carry on, right? Similar case, so let's say there's a weather application which refreshes weather every 30 minutes. And you want to test this business case that after every 30 minutes, you want to assert that the weather has actually refreshed. Now, how will you automate this case? Is it wise to wait for 30 minutes in the automated test? Definitely no. So assume or imagine if your test could tell your app, like, I'm testing you, so can you please for some time change that 30 minutes interval to 3 seconds so that it will be easy for me. And last big problem is UI tests are very, very slow. So a typical use case is for, let's say we have in Badoo, we have almost 1,200 UI tests for the whole application. And for each time, if we log in, so enter username, enter password, press login button, it takes 30 seconds at least. After that, we have got this what's new screen or the onboarding screen, and there can be multiple of these screens, and if we keep dismissing them, it may take another 30 seconds. So 1 minute per test extra for the feature which we really don't want to test in each test scenario, right? We don't want to test login 1,000 times. So imagine your test could tell your app like, I have this token, please log in and don't show me these what's new screen again and again, right? And that basically brings me to the point of what if your test could tell your app. and that's the point of the backdoors. So imagine you are so this is a code of let's say Android application wherein you have a class called login activity, and so you can define a method, let's say method foo, and you can write some code in this method which can be like disabling the random pop-ups, mocking the phone flips action. You can seed some database values or whatever you want which will help you to test, and you could call this method from your test automation code. Now we usually use Ruby, so imagine you can call it using some API, let's say backdoor, and the name of the method foo, and the method basically gets invoked for you, right? So backdoors are basically a way of invoking application code using your test automation code. Now let me show a quick demo of how it works. Okay, can anyone is the fonts readable on the screen? Okay, I'll hide it somewhere. Okay, so there's a sample application here, and I'll explain what it is. There is a text box, it's called, and there is some text, welcome code fest, and there are some actions. This basically reads make bold. So if you tap this button, the font becomes bold, and same is for making it italic and increasing the font size. If you tap this multiple times, the font size increases. And here is the code for this application. This is the create message activity class, and these are the methods for handling on bold, on italic, or on increase text size. Now if you observe, there are few methods which are looking gray, like this one. This is gray because this is not being used in our application anywhere, and this is here because this is going to be used from our test automation code. This method basically takes a string parameter and creates a toast message and shows it on the screen, and we'll be calling this from our automation code. And for that I have a simple Appium script, and this basically requires the Appium lib library and creates the Appium driver and starts the driver and falls back in a debugger. So this is a Ruby client, a Ruby script. This binding.pry line is basically a debugger. So let me run this script. So I say Ruby demo scenario.rb. I have a Appium server running in another console. There's nothing fancy about it. Everyone probably here has seen a Appium test or a WebDriver test at least running, right? So everything is fine. We are in the debugger, right? So let's call this method which is called raise toast with message. What I do here is I say backdoor, and the method name is raise toast with message, and it takes string argument, one parameter. So ours say, let's say welcome. Okay, and then when I execute this, if you see, there is this toast, maybe again. So you see this toast message being shown on the application. What I just did, it call the method which is defined in my application. Now that looks good, but it's not much useful. So let's take an example of where it can be useful. So by default, Appium has some limitations. Like I talked about some driver limitations, like flip, snooze cannot be done by Appium. Some similar way, if you want to verify the styles of the text, for example, if I make the text bold or increase the size, all these things cannot be verified by Appium, because what Appium uses is a UiAutomator 2 driver, and that cannot do these things. Now ideally you would not want to do these things on the UI layer. You can do it. You can verify these styles using your unit test, but just for the sake of example of how we can use backdoors, I'm going to show you. So let's say I want to verify the style or maybe the font of this text box. So for that purpose, I have another method, another backdoor method called message view. And then what this message view does is returns me the instance of a text box with ID message. This is basically this text box. So I'll get an instance of this text box using this method. Let's try this. So here I say backdoor, name of my method is message view, and I execute this. What you see here is, if you see, this is an object representation of this text box in a string format, but the class you can see here is app compat edit text, which is basically the view instance of the text box over there. Now the good part is this is an object and I can invoke more methods on the result on this object, right? So in the Android, the edit text has some methods, like for example, this is a text view. There's a method called get text. All these methods are available to us as part of the view. So I can do method chaining here and I can call this method on the result. So let's say I want to call this method get text size, and it's very easy. This method on the result I call another method get text size, and I see the text size is 54. Now if I increase the size using this button, and it has become bigger and bigger and bigger, it will explode. Yeah, now again I call it and the text size is increased. So this way we can assert the size of a text, which is otherwise not possible with contemporary automation tool, whether it be Appium or any other. Another thing which we can do is, if we want to verify that if the text is bold or not, there is another method available on the text edit text, which is called get typeface, and it basically returns us the object of typeface, which can then lead us to if we want to verify if the text is bold or italic or not. So let's try this last time. So instead of get text size, I say get typeface. Yeah, and this is the object of typeface. Let me clear the console. And on this object I can invoke more method like is bold or is italic. And it says false, and if I make the text as bold using this, it becomes true this time. Yeah, so the possibility is endless. You can define any method which does anything and you can access it from your automation code, and you basically get superpowers. Let's switch back to slide. Okay, so where do we use backdoors? What are the real use cases in our which we have found in our company? The first is changing backend URLs. So we build only one artifact from our CI server, only one APK, and using the same APK we test it against different environments. So if we want to test against staging environment, we use backdoor. We have exposed a backdoor to change the backend URL. We change it using the backdoor and test, and if you want to test it again another environment, let's say prod, we do it using the backdoors. Changing the app locale. So Badoo is available in almost 46 languages, and if we want to do this localization testing, and if we keep changing the device language, it takes a lot of time. What we instead do is we have defined a backdoor which takes the parameter as the language, and when we invoke it, then our application assumes that okay, the local has been changed to Russian from English, and app then behaves in the different way. Getting some parameters from application. For example, if you want to get the current session ID from the logged in user, this is basically needed sometimes for us, because we then take this session ID and ask our backend server to disable things like captcha for that particular session for our automated tests. So that's how we use Backdoor. And I spoke about this already during my example, that we don't want to see what's new screen or onboarding screen on each and every test for all 1000 tests. So we completely disable it for the test we don't want to show it. And at Badoo we do a lot of A/B testing. For the A/B tests which are client side, or which are controlled by the device, they might make the test flaky if we do not set a particular variant of A/B test, or if we do not disable them. So we expose the backdoor which selects a particular variant of the A/B test, and our tests are more predictable then. Faking some SIM card related parameters. So for example, if we want to test our application with a Vodafone SIM card in Germany somewhere, so all those SIM card related parameters we can mock in our application using backdoors. And the last one, but the very important, testing the analytics. So if we want to get analytics data back from the application after a user does some action, and we get it back using backdoors, so that we can perform some assertions on them if they are correct or not. Now that's the use cases. Now let's see how actually in case of Appium we have implemented the backdoors. So this is the current architecture of Appium. There is a Appium client on the left hand side, which can be Ruby, Java, or any other client, and that client basically sends WebDriver calls to the server, which is running inside the Android device, which is shown on the right hand side. The actual server is present inside this UiAutomator 2 server APK. So it's a APK which has all the server code, which basically handles the HTTP calls from the client, right? And this server cannot be booted by itself. To boot this server, there is another application which is the test APK. So this test APK has nothing but just one JUnit test, and the only job of that JUnit test is to boot the second APK, basically the server, HTTP server in the second APK. And this test is able to boot the server because this test is an instrumented test for the second APK. So instrumentation is basically an Android support library which gives the hook into the application. So because the first application is instrumentation of second application, they both run into the same process, and the first one can actually access the context of the second one, or vice versa. So once the server is booted, the server has the UiAutomator 2 instance, and it can basically drive the whole device, and it drives our application under test. Now that's the as is architecture of Appium today. Now to use backdoor, we need to modify the architecture in a slightly more way, slight differently. So if you see, there are two apps. One is instrumentation of another app, and the test APK has nothing but just a test. Okay, so we can take advantage here and we can merge both these two apps in one app. So if we can merge the server part in the test part, so that both the JUnit test and the HTTP server are now in one APK, right? And then we instrument our application under test using this merged APK. So if we can do this, we can basically access the context of our application under test using our server, and we can then call the backdoors inside. We can then put some backdoors in our application, basically cheat codes, and we can invoke them using the server. So all we need to basically do is put some handling of the backdoor in the test server. So moving to the merged APK is something like this. The as is code looks something like this, wherein if you see the blue highlighted lines are basically the first one is the code for the test, which is single file, which is just the test, and the main folder has all the handlers for the WebDriver calls. And we will change it to something like this, wherein we'll move all the packages from our server to the test, and the main package has nothing but just a manifest file. So there is no application as a main application. Everything is just single APK, which is a test APK, right? So this merging part is already done in one of the fork which I maintain, and there is a special backdoor handler in this particular fork. So this backdoor handler, basically when client sends like I want to call these and these methods, the backdoor handler parses the JSON data and queries the context of the application under test, and using some reflection APIs finds the classes and the methods on which it wants to invoke the methods and invokes it. So it's as simple as you do a build in this fork and you get this APK. It's a very long name. I won't read it. But then the important point to note here is the manifest of this APK, which is a merged APK. The instrumentation target package points to the UiAutomator 2 server package, which is still the old one, and we need to change it to our application package because we want to instrument our application using this app, right? And to do this, I've created a Ruby gem. The code is very simple, can be created in any other client, but because we are using Ruby, it's in Ruby. So you just install the gem, run this command Appium instrumenter instrument my application under test, and it basically does two things. It creates another copy of the merged APK, which is signed with our key store, and also the target instrumentation package points to our application under test. And on the client side, basically all we need to do is post some methods which we want to invoke using backdoor. So on the backdoor endpoint, this is the structure in which we can post the methods. We can also do method chaining. We can post more than one method. And if you are using some client bindings, you can in fact do something like this. That's what I showed in the demo. The backdoor which I was using was actually this implementation. You just post it using your HTTP library, and this is how we call it. Just say backdoor and the data, name of the method. Now that's a very powerful feature. It gives you tremendous power. You can basically define a backdoor which destroys your app, right? So with great power comes great responsibility. So while it's a very powerful feature, there are we should be very cautious about when to use backdoors and how often to use and how much to use. And sometimes we might completely bypass the application logic while testing if we are using backdoor in wrong way. So here I have a quick quiz for you guys to check if you understood the concept of backdoor correctly or not. This is the previous example where I showed you the weather refreshes every 30 minutes in this application, right? And we want to test this case. So there are two ways we can put backdoor here. The first one is we can add a backdoor method which changes the refresh interval from 30 minutes to 3 seconds, right? And then in our test we call this backdoor and then test as usual. We wait for 3 seconds and check if the weather has refreshed or not. Another way to do this is we add a backdoor or a cheat code to refresh the weather itself. So let's say we put a backdoor, we call the backdoor and it calls the refresh API and refreshes the weather. How many of you will go with the first one? Okay. And how many of you will go with the second one? Yeah, I there's one. Okay, so if you are going with the first one, you are ethical cheater because you are still cheating, but this is the right way because you are not bypassing the application logic to refresh the weather. Whereas if you are doing the second one, you are a cheater because you are bypassing the logic, bypassing your scheduler, which actually schedules the call to the refresh API every 30 minutes. So the purpose here is to keep the application logic intact as is, but just to simplify it for the tester, right? So the first one is the right way to do it. And yeah, so that's pretty much about backdoors. These are some cool references from which I have used it. Just to give credits to the Calabash projects where I used to work earlier. They already had this kind of functionality because Calabash is based on Robotium, which is instrumentation based testing tool. So they already had this backdoor functionality there. I used a lot of code from there. And there's a blog on our tech blog. You can go and read it as well if you want. So that's pretty much it. Thank you. Spasiba.